Hello everyone, welcome you all. We are going to start with a new training on MAN MEGA engine, which is a very latest two-stroke dual fuel engine in the MAN portfolio. And since this is a low pressure engine, this is operating on auto cycle. We have already made another training module on MEGI, which is a high pressure diesel cycle engine, and this engine is launched in the year 2023. So this is very latest engine in the market, which is based on auto cycle principle. So let's begin the discussion on this, and these are the training course objective which we have outlined. We are going to give you an overview about the MEGA engine, how it started and when it came up, general comparison between MEGA and MEGI, because both these engines are by MAN but they have a different operating cycle. MEGI operates on diesel cycle, whereas MEGA operates on auto cycle. That is why there will be a huge difference in the components of the gas side. Then the safety concept more or less remains same on both the engine, but we will discuss on this. We will discuss on MEGA engine second fuel gas component, because here again, once again, I presume that all of you who are going to take up this training module, you are very well aware about MEC engine, which is based on the same platform, and MEGA is an addition to MEC. So before you come up to learn about MEGA, please refresh your knowledge about MEC. Otherwise, it will be difficult here to accommodate all the details. Here we are going to cover only the gas components, which are an additional component on MEG engine. Since this engine also, when it is working in fuel mode, it acts exactly as a ME engine. So you should be very well aware that ME engine basic components like HPS, HCU and all these components, tacho system and other hardware modules, they will remain as it is. We will discuss on the auxiliary system, which is called GVT, and it is the first safety barrier from the external fuel gas supply system before the gas supply comes to the engine side. We will discuss thereafter the changeover sequences when the engine is running in fuel mode and when we want to change over to gas mode, how this engine will start doing the test, and then only it is going to change over to the gas mode. Then we will show the engine operation in second fuel mode from MOP. I will show you the MOP of the MEGA engine, how it looks like as an overview, and then at the last we will see the gas leakage methods, how we are going to detect the gas leakage on a MEGA engine on various components.
A message for every marine engineer out there. First time joining and scared of what will happen on board? Our Combat Achiever packages show real shipboard videos before you step on, so you join with confidence. Junior engineers still repeating those basic mistakes? Our basic troubleshooting package helps you avoid the same errors we all made on board ship. Fourth engineer, go in depth into purifiers and compressors. Izzat nahi kamani kya? Third engineer, learn auxiliary engine overhauling and boiler testing step by step. To all second engineers and chief engineers and ETOs, hydraulics, maneuvering, electrical circuit diagrams, PLC, PID, reefer and AC system. Guys, troubleshooting should be your forte. अगर जहाज पे इज्जत अपने juniors की चाहिए, तो troubleshooting आनी चाहिए. 24 packages, many more coming soon. 2-year subscription. That's M&D Flex, not a course, but a technical lifeline you need on ship. Check out our free trial videos. Link is in description box.
So these are the outlines of the training course objective, and now we are going to start a new session in which we are going to cover the following topics. First, we are going to discuss about the brief history, how various dual fuel engine in MAN portfolios are classified based on different principle. Then we will compare the MAN MEGA with MEGI or ME, that how it is having new components and additional components. We will discuss MEGA engine gas safety system feature, double valve pipe safety system, which is an additional safety measures in this engine. Then how a window valve incorporation is going to add further safety into the gas operation of the MEGA engine. And then we will discuss an overview of the control system in this MEGA engine, how it is different than ME engine. So let's begin now. So this is how the MEGA engine stands now. They have already sold 284 engine, 248 engine in the market by the year 2024, and they started getting the order by end of the July 2022, and the first engine started rolling out in the year end 2023. These are the engine nomenclature, although this is not MEGA, this is MEGI engine. The nomenclature GA means gas admission, GI means gas injection. As you know, this is a low pressure dual fuel engine. It means that the gas is not injected here, the gas is admitted here. And admission means when compression has not yet started, which is the very first criteria of a Otto cycle engine, where it says that the air and fuel mixture should be pre-mixed before entering into the combustion chamber or before the compression starts. That is where it is called GA and not GE. And usually these engines are supplied with EGR, which is called Eco EGR, in which the EGR needs to be running all the time and not only in the tier 3 zone. And the purpose of running the EGR continuously is to optimize the fuel efficiency, at the same time to reduce the methane slip. That is why in MEGA engine the EGR is an integral part, and EGR needs to be operated all the time, all the day, irrespective of which zone you are working. So in MEGA engine, as we know, this is working on the Otto cycle principle, and the very essence of the Otto cycle principle, which I have explained you in the previous module, that in the dual fuel engine, what all operating cycles of the dual fuel engine, that the first criteria of Otto cycle engine is the heat addition is at constant volume. It means that the air and fuel must be premixed before entering into the combustion chamber. But in a two-stroke engine, we cannot premix outside. So in a two-stroke engine, we are going to introduce the gas just after the exhaust valve has closed and scavenge port is covered. That is where the start of compression is about to begin now, and that is the time the gas is introduced. The air is already there, and this gas air fuel mixture will keep on mixing, and the compression will also continue. So this is very different in the mega engine, where the gas admission valve is there and not gas injector, and also the gas admission valve is located on the liner and not on the cylinder cover, so that the gas is mixed with the air before the compression starts or just after the compression has started. That is the very basic criteria needs to be fulfilled of any Otto cycle engine. That is why this engine is having 2 gas admission valve maximum. It cannot be more than 2. And these 2 gas admission valve are mounted diagonally opposite on the liner above the scavenge port, so that once the scavenge port is covered and exhaust valve is closed, then the gas will be admitted. Again, since the Otto cycle engine from the very basic, you know that it requires an external assistance to start the combustion. It means that Otto cycle engine have lower compression ratio as compared to the diesel cycle. So here there will be an additional pilot injector here, and there will be a pilot fuel system which is going to fulfill this requirement, and this pilot flame is necessary to start this air fuel mixture to burn. There will be again maximum 2 pilot fuel valve only. There cannot be more than 2 pilot valve. So 2 gas admission valve and 2 pilot valve is essential, an additional component in the MEGA engine to start the gas combustion. Apart from that, naturally we will be having double wall gas pipe and other components. So here the gas admission valve is mounted on the liner, gas pilot fuel injector mounted on the cylinder cover. That is how this engine principle goes as far as gas admission is concerned, and here it is not gas injection. So once the gas is admitted, the compression will continue and the gas and air will keep on mixing. Just before the TDC, the pilot fuel will be ignited and the pilot flame will be established, and thereafter the whole mixture will start burning. Since the auto ignition temperature of natural gas is very high, that is why even in diesel cycle engine we still require a pilot flame, but in auto cycle engine it is a must. So this is the classification of the various engines in the MAN portfolio, and Mega stands here, which is LP design, and this is the latest engine in its portfolio, which is based on auto cycle. All these engines which are there in MAN portfolio are based on diesel cycle. So this is only one 2-stroke engine which is there in the MAN portfolio, which is based on auto cycle. These two cycles are very different in its operating principle. So this is where the comparison between MAGI and Mega, as you can see, in MAGI we have gas injector, although in MAGI operates on diesel cycle but still require pilot fuel and pilot injector. That is where the combustion will start, because auto ignition temperature of natural gas is 590, which cannot be achieved by just compression. On the other hand, auto cycle engine, since the basic principle, the compression ratio is lower, so any fuel, even the diesel, cannot have the compression so much that it is going to automatically ignite. That is why all the petrol engine they are based on auto cycle. Here also auto cycle principle, so the gas will be admitted and not injected, and the mixing is allowed for a longer duration rather than here in the diesel cycle. And in this case the pilot injector is going to start the flame, and this is going to make a homogeneous combustion. Here the combustion is heterogeneous, and that is why this engine is not complied with tier 3, whereas this engine is fully complied with tier 3 in gas mode, because here the peak temperature is controlled, here the peak temperature is uncontrolled. So even though both the engines are burning natural gas, which is the cleanest hydrocarbon fuel on earth, this engine is not complied with tier 3 criteria of NOx, and this engine is 100% complied with tier 3 criteria. And that is the reason auto cycle engines are more favorable choice in the market, because it does not require any after treatment and it is fully complied with tier 3 norms. That is where MAGI and Mega are different. This is different alternative fuel as per IGF code, and based on that how much potential each fuel is having to reduce the pollutants, which are SOx, NOx, CO2 and particulate matters are mentioned here. You can go through just for your knowledge. So as you know, the basic drawback of an auto cycle engine is methane slip, because it is bound to happen at lower load and it can vary from 0.5% to 2% also. That is the reason I mentioned to you that in these engines now the maker recommend to run EGR continuously, which is a further measures to reduce the methane slip. It is not for the NOx in this engine. So in this engine the gas is pre-mixed and then compression will continue, and thereafter at lower load there are chances that some gas will leak past the piston ring and remain hidden, and then it will be exhausted to atmosphere without burning, that is causing methane slip. So makers are very much alert, very much vigilant, and there are different technologies coming up in future to reduce the methane slip, which will not have such a significance in the coming future. As you know, the auto cycle engines are very sensitive to load change, because this is a lean burn combustion principle, and where the air fuel ratio is between 2.0 to 2.2 and the band is very narrow. As the load is going higher, the band is keep on reducing. As you can see, the band will keep on reducing. By using EGR we can lengthen the band, but still auto cycle engines are very sensitive to load change, and that is why this requires a load ramp, and we are not going to suddenly change the load up or down in both cases, because if we will change the load suddenly, the air fuel ratio might shift to the right side, which will cause misfiring, which will make the combustion unstable. And if the air fuel ratio shift on the left side, then we will have pre-ignition and it will cause knocking. That is also one of the drawback of Otto cycle engine, and knocking is very dangerous to the engine components. That is why it is very important to take care of the air fuel ratio in the Otto cycle engine. So in Otto cycle engine we are having one system they have made in such a way that by EGR they can maintain a air fuel ratio band to little bit wider and to avoid the misfiring or auto ignition situation. The Otto cycle engines are also, by using EGR, as you can see, they can expand this band, but still as the load goes higher and higher it will keep narrow. So with EGR, this blue band indicates the EGR effect, which is further stretching this band, and this stability of the engine to some extent enhanced also by using EGR. And that is why in this engine we need to continuously run the EGR while it is in service. So they are using a Mega Opti software here, which always optimize the air fuel ratio between this window. The Mega Opti is basically a software by the engine maker which keeps the air fuel ratio between this limit and within the optimum point of operation and preventing FRC activation. FRC is called fuel ratio control, that is only required when the gas load is unsustainable, and that is the time it is going to activate the fuel and it is going to reduce the gas load so as to avoid the gas trip. That is how the software is designed in this engine. The Mega functionality by floating compression ratio to scavenge pressure, because they need to optimize the engine performance at all load. So compression ratio to scavenge pressure ratio is used as a countermeasure detection for pre-ignition and knocking. This ratio is always checked by the engine software, and this is a parameter on which they take countermeasure so that neither misfiring nor knocking can happen during engine operation. And this development is still in process. The Mega Opti, they are keep on optimizing the software, and in the due course they will make the engine more optimized even at higher load condition. So in this software they are having a option called FRC control, fuel ratio control. In other engine we call dynamic control. That this is the similar way the other engine maker is also quoting. So what happens in case of higher load, that when it is detecting that this is going to be on a higher side cylinder pressure, or fuel oil is too much advanced, or the peak pressure is going too high, dp by dt on the maximum side, in all these conditions this is going to give order for the fuel index to increase, and conversely the gas index will be reduced. That is called FRC. And during FRC operation the fuel ratio can go up to even 20% in some condition, usually 5 to 10% for momentarily, just to balance the combustion in this phase, and once the combustion is stabilized the fuel index will be reduced. That is called FRC in the Mega engine. So FRC detection will be detected, and accordingly the fuel will be increased and the gas will be decreased, so that the combustion will remain stable and it is not going to have any kind of gas trip. So that is how the Mega Opti level is keeping it optimized by using the software. At this point, when the engine reaches the peak pressure, the FRC will be activated. It means that the gas will be minimized, the fuel will be increased to balance the condition, and it will continue till the time it comes to this level. At this point of time FRC will again become deactivated. So fuel ratio control, and in other engine maker it is called DCC, dynamic combustion control. It is similar condition, and this is only required in harsh condition when engine cannot make up with this load in gas mode only. Now there is another software feature added here called cleaning cycle. Cleaning cycle which will going to inject fuel oil on the main fuel valve during gas running, because during gas mode here the main fuel injector is remaining idle at all time. And suppose the gas mode is running for days continuously. What is the drawback? Because here we have a separate pilot fuel injector. So the main fuel injector is standstill for very long time, which can cause lot of stress, and in worst scenario it can clog the needle, it can seize the needle also. That is why there is a cleaning cycle incorporated, that every 10,000 cycle they are going to give a 2 normal lift. 2 pulses it will give, so that the injector will still operational and it will not cause a long idle period. That is also features given in the software. Jacket cooling water recirculation system, which is a new features they have added, that they have added the recirculation pump, and in this way they are going to maintain higher jacket temperature, and exhaust valve and cylinder cover will be maintained close to the similar temperature, which is close to 85 degrees Celsius, but the jacket will be maintained close to 120 degrees Celsius. So this feature is going to further optimize the thermal efficiency of the engine. This is the general overview of the fuel gas supply system for the mega engine. Here the compressors are low pressure compressor, because we don't require a high pressure gas supply here. The gas pressure maximum required is 12 to 13 bar and 14 degrees Celsius. So the FGSS system will be much more simpler here, not like MEGI